Welcome back. Welcome to this short section on generics. We were using generics extensively when we were working with collections. In this section, you will learn to create classes and methods using generics. More importantly, you will understand why we need generics. Let's get started with the why question. Why do we need generics? That's what we would discuss in this specific video. As usual, let's create a new project, right? We would want to create a new Java project. I would call this generics and I would leave everything as it is, and you can go ahead and click the finish button. When you click the finish button, you would see that a project is created. I'll go ahead and create a new class and I'll call this generics runner, and I'd add a main method plus finish. We have a main method. That's cool, right? So let's say I'd want to create a array list like class, but something which would do a little bit of validation around it and things like that. I'd want to implement a custom array list class for myself, which would do a little bit more than the typical array list would do. So let's get started. So I would want to say my custom list, and over here I'll create new my custom list. Let's create the class. Create class my custom list. I'll use the same package. We are in package generics. Oops, com dot in 28 minutes dot generics and say finish. Right, so we have a package com in 28 minutes generics, and over here it's in generics. So let's change this as well, com in 28 minutes dot generics, control 1 and move generics.java to the package. So now, the structure we have right now is we have com in 28 minutes generics, where we have generics runner and my custom list. I don't need the generics package anymore, so let's go ahead and delete it. Okay, that's cool. So we have the structure ready. Now in the my custom list, I would want to have a array list. So I would want to have a list. Array list is equal to new array list. The compiler is complaining, saying you are not saying what you will hold in the array list, right? So I'll say string, right? So new array list of string. So that's what you would want to store in here. And now I would want, let's say, to be able to add elements to this. So let's say public void add element and string element, and let's say all that we do is list.add the element which is passed in. Let's keep the logic very simple, and let's also say there is a remove element method, public void remove element. There is some custom thing that you would want to implement. Let's not really worry about it for now. And now let's say list.remove and element. So we have a very simple class where we can store a list of values, add and remove elements which are present in here. The design is not really perfect in the sense that we are not really returning whether a remove is successful or not, but that's okay. For now, what we are focused on is on the generic stuff, right? So I have created an instance of this my custom list in here. So list. Now let's say I want to say list.add element and element 1, element 2. I can also do remove. But let's say I would want to create the same class with integers. So I would want to say I would want to create a list using numbers. So I would want to store integers. So I would want to store list2 with, let's say, integer dot value of 5. Over here I would want to store integer dot value of 7. My implementation as it is right now only works for one data type. What is that data type? The data type is a string, right? If I want to use integer, or if I want to use a custom class I defined, if I want to store elements of that type, my implementation will not work, because we have hard coded our implementation to use only a string. This method will only accept a string, this method would only accept a string. So my implementation is tied to a specific data type. How can we create classes which are not tied to one data type. I would want this class to work with integers. I would want this class to work with custom classes I create. How do I do that? That's basically the problem that generics aim to solve. If you use generics properly, then we would be able to insert any kind of elements and remove any kind of elements from this specific list. Now that we understood why we need generics, what is the problem that we are trying to solve with generics, in the next step, let's move on to implementing generics for the my custom list. I'll see you in the next step. Until then, bye-bye. In the previous step, we saw why we needed generics. In this step, let's implement generics for the my custom list. A lot of people tend to think that generics is really complicated. Actually, generics is very simple thing. All that you need to do is you have to define a generic type. So this is angular brackets. So between angular brackets, you can define a generic type. Once you do this, then what happens is my custom list of T. As soon as I say my custom list of T, you would see that there is a simple error coming in here. It's saying my custom list is a raw type. Try and use the parameterization. So if I remove this parameterization which is present in here, then you can see that there is no warning in here. But as soon as I say T in here, it's saying, okay, class accepts a type parameter. So you can specify a type parameter. So here I can say of string. Here also I can say type. What we are doing in here is as soon as I add in a type in here, I can specify what type I would want to use in here. It's not sufficient if I specify the type in here, right? I would want to also be able to use that. So over here now for the list 2, I can say this is an integer. That's cool, right? So now I can say this is an integer and I would want to store integers in it. But the add element is not accepting integers yet. How can I make it accept the integer? That's by saying T in here. So array list of T. So the underlying data structure I'm saying is should use the same type. So instead of string, I'm saying array list of T, and the same thing instead of string, I'm saying T, and instead of the string in here, I'm saying T as well. So wherever we had string in before, we are changing it to T, and this will help us in getting our functionality working, right? So now I still have an error because I was not using list2 here. List2 should be what I've been using. So list2, I can add integers to it, right? That's cool, right? So now I can actually, let's implement a toString, public string toString, and let's just return list.toString for now. Let's not do a complicated implementation. It's a very simple implementation of toString. So now over here, I can print my list, sysout list and sysout list2. So I can have a list with storing strings. I can have a list storing integers. And you can see that this list is storing strings, this list is storing integers. Actually, if you look at how array list is implemented, that's exactly the same way. So if you go to array list, java.util.arraylist, Control Shift T and go there, you'd see that they are using E in here. And if you look at all the methods, let's look up the add method. You can see that it's add E, add E. So the type is E, add E. E is the thing that they use. That is exactly what we are specifying as T in here. I prefer using T because T stands for type and you can use any type in here. The naming convention which is typically used over here is to use a capital letter always. And also, if you want to actually expand it further, the best way to do that, if I do a right click, refactor, rename, you can say type. So it should be all caps. So to indicate that this is a specific type. If you just have one type being used, I prefer using just single letter T. And if you're consistent with this, people who look at this code will also be able to understand it very easily. I would want to add in another method to this list my custom list, I would want to return the element from the list back. So what I would want to be able to do is I would want to be able to say string value is equal to list dot get of based on the index. So I would want to get the first element, it's get of 0, right? Over here also very similar thing. I would want to be able to do string, here it's not string, here it's integer. Integer, I would say number is equal to list2 dot get of 0. So I would want to be able to do this. I would give it as an exercise and let's see how to solve it in the next video. So try to think about this and I'll see you in the next step. Until then, bye-bye. Welcome back. I hope you got a chance to work on the exercise. If you didn't, pause the video in here and try to solve it. So I would want to be able to return a string as well as an integer from this specific method. How do I do that? Control 1, I'll go and create a method, right? So if I say public string get int of I and say list dot get of I, or I think it's better to say index, I'll rename this to index, that's a better name. It does not compile because there are two reasons, right? One thing is I don't want to just restrict it to a string. I want to use integer if it's integer, string if it's string. So the way we can define it is by saying public t. So public t get index and list.get index is what we would want to return back. And over here I can save this, and now if I run it, you would see that I can actually get the value. So over here, let's print the value, not the list, and over here I'll print the number. So we are printing the first elements in both the lists. Okay, element 1 and 5. That's cool, right? So now what we are able to do is we are able to return the type. So the important thing here is we are able to return the type. Here we were passing the type as a parameter. Here we are able to return the type as a return value. With generics, once you specify the variable type on a class, wherever you would typically specify a type, in all those places you can use this as the type. And based on the usage, so if here I'm saying it's string, so wherever the t is present, it would be replaced by, and in this case t is replaced by an integer. In this step we looked at how to create a return value of the type t. We created a simple get method and returned a value of type t. I'll see you in the next step. Until then, bye bye. Welcome back. In this video, let's look at a couple of puzzles, simple puzzles related to generics. Let's go to the generics runner, and over here right now we are using string and integer. Let's say I would want to be able to use this my custom list only with numbers. So I don't want to allow it to be used with integers. How can I do that? The way I can do that is by saying t extends number. So now you would see that as soon as I say t extends number, there's a compilation error. It says string does not match this. It says string is not a number. If you look at the hierarchy of the integer classes, right click by saying open type hierarchy, right click and say open type hierarchy, it would bring up the entire type hierarchy. As you can see, integer inherits from number. Number is an abstract class with a few abstract methods in here, and integer inherits from there. This specific class, now I can use it with long, and I can use long elements in here. So I can say long.get0, and I can add an element 5L, 7L, but I'll not be able to use a string with it, right? So that's how you restrict. The advantage of restricting this is now I would be able to call all the methods which are available on element. So I can go here and say element.byte value, double value, float value, because these are all the methods which are present inside the number class. So anything extending number, I'm sure it will have all these methods present. So that's the advantage. So when we restrict the classes that can be used in here, the advantage is all the subclasses would be implementing this class, so we can use methods from this specific class. That's the advantage when we use t extends number. Until now, we have been using generics with types, right? We defined a generic along the class and we have used it in here. Generics need not be restricted just for types. You can even create generics with methods as well. For example, let's create a simple static method. So I can say static x. X is kind of a type. Let's say do something. And I can use x as the type in here, x value, and return value. Where are we defining x? What is x? What we can do is say x. I just had to move the static keyword before the method. So static, the type, and we are saying here that we are accepting the value of the same type and returning a value of the same type. This method is not really doing anything. To make it do something, let's do double value. And to be able to do a double value, value dot, only the methods in the object class are typically present, right? Because now for this method, you can call it with any things, right? So I can go to main and I can say double value and call it with a new string. I can call it with a integer dot value of a specific value 5. So there is no restriction. I can even call it with a new array list, right? So there is no restriction on what we are doing in here. Because this method, what we are saying is, it's because I have to import the array list. Now if I fix that, you can see that this can be passed in here. And what this method does, it just returns that specific type. So here I have to have a string to receive it. So string value is equal to double value. And I can have string number. Will this work? Nope, because this would return the same type x. So whatever is the value you're passing is the value you would be getting back. I mean, is the type of the value you would be getting back. So this should be a integer. And when I'm passing a list, the type would be a array list. The real benefit of doing something like this comes in when you actually restrict the type. So if I say x super of list, so anything which is implementing list, I can use it in here. Sorry, actually x extends list. So anything that extends list, I can use it in here. And over here, instead of double the value, I would say duplicate list. So I'll say duplicate list, I'll have void as the return type, and let's accept x. And over here, what we'll do is we'll duplicate the elements in the list. So what we'll do is, let's call this instead of value a list, and list dot add all, again the same list. So what would happen? All the elements in the list will be duplicated, whether it's array list, whether it's linked list, all vector, any implementation of list, you'd be able to use it and duplicate the values irrespective of the type of list you are passing in. So over here, let's create a very simple list. Let's one of the things I've done is I've renamed the variables to value 1, number 1, list 1, because there were already variables which with those names below. So you can fix that too. And now I can actually create a new list, right? So array list numbers is equal to new array list. We would want to be able to modify this. That's why I'm not using list of directly. So array list of, over here I can say list of 1, 2, 3. So we are creating a list with elements. Let's say it's array list of integer, right? So that's basically what it is. And now I would say duplicate numbers. What happens? And let's say sysout numbers. The numbers should get duplicated. 1, 2, 3 should be added again, and I should see 1, 2, 3 2 times. So you can see 1, 2, 3, 1, 2, 3. Not just with array list, but you can actually use any type in here. So you can use linked list, for example, linked list, organize the imports, and then run. Oops, 1, 2, 3, 1, 2, 3. So irrespective of the type, this method would work. Any class which extends list, I would be able to use it. The beauty of this method is the fact that in here, all the methods which are typically available in the list class are available. So all the list methods are available. So if you want to implement generic logic for any of the implementations of the list, I can do something of this kind. So this is a very generic method. In this step, we are looking at a little bit of complex stuff around generics. We talked about extends, we talked about how you can create a generic method, and we talked about how you can use extends and the generic method together. I'll see you in the next step. Until then, bye-bye. Welcome back. In this last video on generics, let's look at something called wildcards. In the previous steps, we looked at how to create a generic class. We created a generic method. Now, we will use wildcards in method arguments, and these wildcards can also be used in local variables and member variables. Let's get started. So let's say I would want to write a method which would be able to do the sum of any of the list of numbers. So what do I mean? Let's look at it right now. So let's create a static method, and let's say it returns a number back. So I would want to return a number back, and I'll call this sum of number lists. I would want to be able to accept any list that extends number class, and I'll call this numbers. Cool, right? So now this question mark here is called a wildcard. Any list of type extending number class is a valid list. So any list which is extending number class can be passed as a parameter to this. Let's implement the logic for it. So I can say instead of number, let's have double as the result value. It makes it very simple. So I'll say double value is equal to 0.0, and I can say for number in numbers, I can start with actually sum, right? Double sum is equal to this. So sum plus is equal to, I can say number dot double value. Let's take double value, add it in, and return this sum. Right now, this method which is present in here can be used to sum any lists. So I can say sys out sum of number list and pass in list dot of, let's create integer list first, 1 2 3 4 5, and after that I would create a double list, because by default all floating points are double, so this would be a double list. And you can even try long list as well, right? So I can say list of 1L, 2L, 3L, 4L. So this would be all long literal. So the list created would be of the type long, right? So you can see that now this particular method would be able to add all that up. So you'd be able to see 15.0, 15.5, and 15.0. So that's cool, right? So it's able to add integers, it's able to add floating points, and it's able to add longs. This wildcard in here is called a upper bounded wildcard. And there are other wildcards called lower bounded wildcards as well. So how does that look? So you can say question mark super number. So you're saying the lower bound is number. Say void add a couple of values, and now over to this particular list I can add in numbers dot add 1, I can add in 1.0, I can add in 1.0f, a floating point, or I can even add in a long. Any type which is a subclass of number can be added into this particular numbers. This is called a lower bound wildcard. Now I can execute this list. Let's start with a simple execution of this, add a couple of values, and let's just create a new array list and send it out there. I'll take it as a new array list of, oops, let's create a new variable in here. I'll say list empty list is equal to new array list of number, and I can say empty list in here. Oops, it's a void, so I cannot do system.out.println of that, so I can say sysout empty list. And you can see that this list has all the values that we have passed in. In this video, we looked at the upper bound and also the lower bound wildcards. Upper bound helps in implementing common logic for all the lists which are extending number, which are subclasses of number, and the lower bound helps us to add a lot of different values of the types which are subtypes of number. In the last few steps, we learned a wide variety of things about generics. When we look at generics, the most commonly used type of generics is the generics with types. So this is the commonly used generics. So this is the most important thing for you to understand very well. Other commonly used generic is the one which we used with a method. So here we created a method, we declared a generic in here and used it. The other two examples that we looked at, the upper bounded wildcard and the lower bounded wildcard, are not so frequently used, but it's always great to understand them. I hope you had a lot of fun in this section, and I'll see you in the next section. Until then, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.